Hello, everyone. Thank you for joining us. I'm going to take us through a continuation of what we started last time. That's on Python. The first course we looked at, the first webinar, which was last month. The first one we looked at was data visualization. And today, what we intend to do is we want to finish up what we started with last, and then do some more machine learning experiments. So without any waste of time, we're going to start straightforward. But before we go to our notebook, what we're going to do today is, because it's mainly going to be machine learning we'll be doing today. We'll be doing some predictive models. So the first thing we're going to start with is I will take us through some explanation of what machine learning and prediction and a few things that we do. It's not going to be mathematical or anything that's going to be too hard for people to follow. So without any delay, I'm going to start now. Okay, so in machine learning, what we normally do is, and that is some part of what we started looking at last month. I keep on saying last week. We have some data which is normally called the X, and this is the independent data. When we say independent data, what we mean is data that does not depend on anything. For instance, when we talk about, let's say an example of a car. If you talk about the car, its model, its size, engine size, its color, this doesn't depend on anything. These are values that we normally stack and put in a matrix, like what I'm showing you here, the X here. And then in the Y normally is the dependent data. And this is normally, for instance, if we're talking about this example that I gave with cars, so there we could put the car prices. So obviously we know that those things that are in the X, they are defining what the Y should be. And a machine learning algorithm, normally what it does is it takes the X as input and it gives you the Y as an output. That is maybe the price of cars, the price of houses, and we'll look at all these things. So normally in machine learning, we have these two main variables, the X and Y. The X is independent and the Y is dependent. So for instance, if you have your data like this, what you normally do is, so for instance, look at this example I was given of the car. So for instance, we have the makes of the car, the model, the engine size, and then the prices are on the Y-axis. And normally what we do is we split the data into two. Normally, a huge part of the data is going to be used for training, and I'll explain what this training means. You can see that from this slide, you can see what I'm showing is that there is the X trend and the Y trend. So these two will be used to teach the machine learning algorithm how to map the relationship between the inputs and the output. You don't have to, I'm not going into any technical information, too much mathematics or anything that will confuse you, no. Then we're going to hold back some part of the data, which is, you can see where I wrote X test and Y test. So we'll keep these two just to evaluate and see whether our algorithm is learning well. So during learning, what happens is we call this part of the learning process, we call it the training phase. And this is supervised machine learning. What it means is we feed in the X trend, the X variables that define the Y variables, we'll be feeding them into the computer, and the computer will be learning from them. So when the computer is fully learned, look at the arrows. You can see that they are all showing that the X and the Y are going to the computer. So we're teaching the model. And the model is nothing more than just a mathematical equation that defines the relationship between the X trend and Y trend. Then when it is fully trained, we now give it X test. You can see from this, and this is the testing phase. So we give it the data that we kept on the side, the X test, but we don't give it the Y test. We give it the X test and now say, my model, based on what you have learned from the mapping of your training data, what is the prediction? Predict my Ys for me. And it does a prediction, and this is what we're going to see today. And so when it does the prediction, since we have hidden the Y test, that is the corresponding Y values of the X test, and we've just told the machine to do the prediction for us, we take what it has predicted and we compare it to our Y test. And this is where we evaluate the performance of the algorithm. If an algorithm is very good, you see that it is getting the accuracy is very high. And if it is doing badly, this will tell us. And this is what we're going to go through today. And what I've just explained is called supervised machine learning. And why is it called supervised machine learning? Because we teach the computer, when we're teaching the computer, when we're creating the model, we give it the X values, that's the independent variables, and the Y values. We keep giving them these two pairs until it is fully trained. When it is fully trained at test time, or when we put it into production, we just give it the X variable. So ideally, it's only the X variable that you feed into the trained algorithm. And there are two main types of these supervised machine learning algorithms. There is one called the regression algorithm, and there's another one that with the classification. What makes the difference? The major difference is based on what you have as your independent variable. That's the Y variable. If your Y variable is continuous data, what we mean by continuous values that have numerical points, for instance, height of people. Somebody can say my height is 1.5, somebody says 1.6 meters, somebody says 1.8. You can see this is, we have these small points in between. So this is continuous data. So whenever we have data like that in our Y, then definitely we are going to use regression. And an example of a popular regression algorithm is linear regression, which we are going to see today. Secondly, if your data is discrete, what we mean by discrete is when the data doesn't have points in between. For example, when we're talking about the human race, we say somebody is African, somebody is Caucasian, somebody is Indian. So you see, these are discrete values. So when we have discrete values, then in that instance, the machine learning algorithms that we use are classification algorithms. Another example is like disease categories. Maybe you could say cancer, you could say malaria, you could say. So you can see that these are categorical data and they are discrete. And one popular algorithm that is being used is the logistic regression. We'll be looking at it if time permits today. Without any waste of time, I'll just show you what these two algorithms actually do. For instance, the linear regression is just in a layman's language, without going technical, assume that the linear regression is just a curve fitting exercise where we fit a straight line to our data. That is what we do during linear regression. So during training, what we are doing is we fit this line. So that training phase that I showed you, we fit a straight line to the data. Then once we build the model, during test time, we just use the slope of that line and the intercept of that line. You don't have to know this. If you don't know this, don't feel scared. But we use this information and then we make our prediction. So meaning that if in the future we give it the data, it should be able to tell us what's the Y value. Then for logistic regression is similar to linear, but the linear regression, but this is used for classification. So what it does is it takes that line that will fit, that straight line that will fit into our data in linear regression, we fit another function to it, which forces the values to either give you a probability of 1 or 0, and that is why it is good for classification. So you could classify two things as either 1 or 0. So for instance, let's say you have data of human beings, you could either classify the human beings as, oh, this guy is African or non-African. So in a nutshell, this is what I wanted to give you, the information I wanted to give us today. And we'll now start with, so with this information that we've seen, we will now go ahead and start working on what we did last time. If you haven't forgotten, last time we stopped after we had finished visualizing our data. And what I intended doing last time was for us to do linear regression based on the data. And when we go back to the data, if you have forgotten, let me show us our data just to give us a recap. This was the data we used last time. Let me zoom it so we can see very well. So last time, this was the data we used. And I said that this column, MEDV, is the dependent variable. And you can see that clearly the data here is, so last time, the data we looked at was this one. So this was the data we looked at last time. I'm sorry, I didn't share the screen. So this was the data we looked at last time, and MEDV, which is this column that I've highlighted, these are the values that we looked at that we said were the dependent variables, so they should be the y-axis. You can see that these are continuous values. And we looked at the correlation between LSTAT and RM. They were the two values that had high correlation. Let me quickly remind us by showing you my notebook. So the notebook we looked at last time, if you look at the last thing we looked at, this was it. So we had these two figures where we looked at RM, we plotted it against MEDV, and we plotted LSTAT against MEDV. What this is telling us is that these two variables, LSTAT and RM, they are, of course, independent variables, and they are highly correlated with our MEDV. So what we're going to do today is we're going to stack these two values. That is, so we're going to get this value RM, and we're going to take this LSTAT. These two values, we're going to assume they are the X variables. So we have this as X1 and this as X2. So we have two values. And then the Y value that we want to look at is this MEDV. And in summary, what we're going to do is we're going to stack the X values, the two X values, with the MEDV. Then we'll split the data just like I've shown us. We'll split the data into training and testing. Then we'll use the X trend and Y trend to teach the machine learning algorithm. And if I may ask, which algorithm do you think we should use? Is it a classification or regression? Based on the values of MEDV, what do you think? I'm sure you'll be saying we should use regression. Why? Because these values are continuous variables. They have points and all these values. So we're going back to our notebook. And because I know it is possible that all of us will have forgotten how to try this, and again, we're going to start open another notebook on Google Colab again. Go to this link, copy the link. So we're just repeating what we did last time. And go to your web browser, navigate to that link. After navigating to the link, there's the Google Colab web page. Click on new notebook. So in a way, I'm just revising a bit of what we've done. So we have a new notebook opened. What's the first thing we should do? We should click on connect. Look at the top right hand corner, there's connect. Remember to connect. It will say allocating. It is allocating, yeah. Initializing connected. And remember, if you want to change the runtime to use GPU, that's the graphical processing unit that makes computation very fast, especially machine learning algorithms. You go to runtime and then go to change runtime type. You come here, it says it is using Python 3, you don't have to change that. Come down to hardware accelerator, choose GPU, and then save. So this is basically what we did last time. Then you remember the first thing we said was to import some libraries that we're going to use. So some of the libraries we're going to use today, I will explain them. So these are the libraries we're going to use. We're going to import NumPy as NP. NumPy, I said, is a numerical, it's a library for doing mathematical computations in Python. Pandas, I said, it is a library that's used for data analysis, and that was what we're using last time to read CSV files. Then today we're going to have introduced some libraries. This library, sklearn, scikit-learn, is used for machine learning. It contains all the machine learning algorithms in Python. It is a free library, and if you can see that, for instance, this first line, even if you don't understand fully what it's doing, it is importing linear regression. So you can just type this exactly into your notebook and click enter. Shift enter will run the cell. Then the next thing we're going to do, so after doing that, the next thing we're going to do is to mount our Google Drive. If you haven't forgotten what we did last time, this was basically what we did last time. So I hope you're with me. So last time what we did was we imported all those libraries, the libraries I've just shown you, and then the next thing is we mounted our Google Drive. So that's what we're going to go ahead and do right now. So we'll come here and then mount our Google Drive. Do you remember how we mounted our Google Drive? If you have not, fine. If you have forgotten, here is the code. Here is the code. So what we did last time was we had data, and we said, so yeah. So last time, sorry, before then, we have to like mount our Google Drive. So before we read the file, we have to mount our Google Drive, and this was what we did last time. So if you have your notebook, you see that this is so straightforward. From google.collab import drive, drive.mount, just call this variable. Type this in, and then because our Google Drive, this is the structure of our Google Drive. We have drive. While you're inside drive, there's my drive. Look at where my cursor is. Then there's data. This is a directory that we created last time. And inside data, we had our Boston housing.csv. This was the file that we read last time. So that's why here, after mounting, what we have to do is we have to call. So sorry, why is this? So yeah, so we'll mount a drive here, and then to read our CSV, we just call mount drive, my drive, data, which is our directory, and then the CSV. If you are here, all you have to do now is either click this place symbol here just to run the cell, or the shortcut is just click on Shift and Enter. So by doing this, it is going to do two things. One, it will mount the drive, and two, it is going to read the CSV file into this variable called data. And you remember exactly what we did last time. What we did was it will ask for permission. You click on this permission, it will take you to your Google Drive account. So you have to log in with the account that you're using. Then we'll copy this. We'll copy this line, and then come back to our notebook, paste the values you've just copied, hit enter. If everything is successful, you see that the cell should finish executing. And once it is done, you can see that it says mounted. So mounted, but today what I've done is not just mount it separately. After mounting, I also call the CSV file. So right now I've called our CSV file into this variable data. Without any further delay, let's see what we have in our data. So data.describe, this was what we did last time. And this was what showed us. Boom, here it is. You have your variables, you have the mean, the count, and all these basic statistics about it. So without any delay, what we said was that MEDV, which is the last variable here, last time we looked at, it had a high correlation between RM and LStat. And we said that so LStat and RM, out of all these variables, all these other variables have the potential of being X variables, while MEDV, which is the prices for the houses, is the one that is supposed to be the Y axis, which is the price depends on all these X values. But we said we are going to use only values that have high correlation. So we're going to choose these two and make them our X axis. And then, sorry, our X variable. And then MEDV is going to be our Y variable. And so what we're going to do is come to the Excel and type X equals to PD, which is pandas, right? We're calling pandas to do this job for us. Concat. You see pd.concat. Then inside here, we're going to call the variable data dot the variable name we want to put in LStat. You can see as easy as that. Then comma data dot rm. So now we have put these two variables. We're trying to put these two variables, these two columns together. And so this is, and don't forget, write this value, our axis equals to 1. And then our y is going to be data dot MEDV. So what we've done is we've selected two columns from our data and stacked them together to form X. So we have two columns, X1 and X2, and then as X, and we have Y, which is this. Run this by clicking on Shift Enter. Having done this, we can easily try and check what we have inside there. For instance, if I was to write x.shape, you see, x.shape tells me what's the shape. So what's the dimension of the variable? You can see it has 506 lines, which is the total number of data we have inside. And there are two columns. That's because we have two columns here. If we were to type y.shape, you see what it says. Y.shape is just 506. So because it is a single column. So now we are ready to start our machine learning. And because we said y is a continuous variable, we're going to do linear regression today. And remember in my slide, what I told you is when we have the X and the Y, the first thing we have to do is to split the data into training data and testing data. So now we're going to split, and we have this excellent library, machine learning library, that does it for us. All we have to do is write xtrain, comma, xtest, comma, just keep on typing. Y train, Y test equals to train test split. This is one of the libraries that we imported that has this function, and this function conveniently just splits our data. What it takes as input is we call the X variable, the Y variable, and then we tell it the test size. So what the test size means is what portion of your data do you want to keep as test size. So here let's write 0.2. So we're using 20% for testing. So that means 80% of the data will be used during training. So, and don't forget, write random state. Why we write random state is for replicability, because when you split this data, it does it in a random way. It shuffles the data before it splits it. So if you write random state of 1, it means that if I write random state of 1, you write random state of 2, your data and mine will be different. They are split because they will be shuffled. So you should write the same random state if you want to replicate whatever you've done, so that it will be easy for you to share whatever you've done, so that somebody can try it and get the same result too. So run this cell. If you run this cell successfully, it means that our data has been split. And to prove this, let me show you. Write x.shape. xtrend.shape. You see, now we have 80% of our data is in xtrend, which is 404. And
we have a question here.
Okay.
Hello.
Hi.
So someone was asking.
Okay, assuming we have more than one data set to work on, how do we import more than one data set? Sorry, please. Will advise us to let's if we can, let's try and stick to what we're doing, and when we're done, then we can answer this question. Let's try and use the small data. But honestly, if you have more than one data set, it is as easy as just importing using the same method. Because for instance, what I've done now is I've imported the data from CSV and I saved it into what variable? Data variable. So if you have another data, you can also import it into another variable, maybe say data 2. And so what you can do then there is as easy as what you can do at that point in time is once you have this data, you can then use this concat we've just done here. So for instance, look at what we've done here. We took this data. Let's assume that you have this data 1 is in one variable, and maybe you have another data which you have called into another variable. Look at this line. This line you use to call your data. So if you want to call another data, you could call this another data into another variable, just maybe data 2. So that will call the second data. Then if you want to concatenate some of the columns, for instance, you want to take some columns from here, some columns from there, all you have to do is use this line. Look at the line here. pd.concat. Then I said data.lstat. So if you want to get columns from another data, let's say data 2, then you have data 2 whatever column you have. So that's how you do it. And I can elaborate more on this once we're done with this. So I hope that is clear. And if that's clear, then we'll go ahead and then try and do the linear regression now, after having split the data. Is there any question with regards to splitting? No. So I'll assume that everyone is following so far. So far, so good. So we have split our data, and like I said, this line of code that we wrote here, trend test split. Where did we get this trend test split? Is because we imported it here. You can see from sklearn.model selection import trend test split. That has a function that just, if you pass in your variables x and y variables and the test size, it will split according to this percentage you've given. So now x trend is 404. If we have to write xtest.shape, you see what you have there. It should be 20% of the data. So we have it as 20%. So if you remember what I said in my slide is we take our x trend and y trend and then we train the algorithm. And that's as easy as running a single line, one single line. What we are required to do is to call the model. So model equals to linear regression. That's what we say. So by doing this, we have defined an instance of the model. And where did I get this linear regression from? Is because I've imported it here. So it is everything. This import helps us with all this. So we just say model equals to linear regression. And so that means we have defined an instance of the model. Then we now say model.fit. This is the training. You can see the training is as simple as just calling a single line. So there I will say x trend, comma, y trend. because it is a supervised machine learning algorithm, it is expecting me to give it two variables. That means with just this, now our model has been trained. So that means model now has mapped our X trend and Y trend. And what they say we're going to do once we have a model, the next thing is for us to now feed in our test data, X test, to see what the model will predict. So what we're going to do now is we're just going to call the predict. So it is as simple as one line. So to predict, we say Y predict, that the predictor value for Y would be model dot predict, and we'll pass in X test. So you see, so that means now we predicted. So what we have here is what Y test is the real value, the ground truth for the Y variable for the testing data. And Y predict here is what the model has predicted. Now the next thing is for us to ask ourselves, how is the Y predict, how close is it to Y test? And one of the major algorithms used for doing this is the mean absolute error. That's one of the metrics that is used to measure this. And what the mean absolute error does is it just compares each value to the next value. That's one value in Y predict. Because if I was to say print Y predict, comma, and Y test, so you can see what we have here is some of the values on Y. So these are some of the values on Y predict, and these are some of the values on Y test. Maybe this is not quite clear. Let me print them in different cells. So this is Y predict, and this is the corresponding value for Y test. So what we have here is that Y test, the first value in Y test is 28.2, and what our Y predict, the first value there is 28.6. You can see it's not far. And look at the values. So to compare these two, we just use the mean absolute error. So we can say mean error. We can just define a variable mean error equals to mean absolute error. We pass in two values, Y test and Y predict. And that's the mean absolute error. So with just this single line of code, we have computed the mean absolute error, and we can print it. Print mean error, and that's 4.5. If you remember in statistics, what this means is, and that's the error is quite small. Honestly, what it means is we in our prediction, the model from just this model that we trained on only a data size of just 404. It is able to make prediction that has only the error of 4.5, meaning that whenever it predicts MEDV, it can make an error that is not greater than 4.8. So for instance here, it predicted 28.61 and the real value was 28.2. You can see how close it is. Here the second value is 28.15 and it predicted 23.9. And the next value here is 17.4 and it predicted 16.6. You can see how close it is. The next ground truth value, sorry, this is the prediction, this is ground truth. So the next ground truth value is 22.0 and it predicted 23.8. So with that, we have just done linear regression, which is a basic machine learning algorithm, the simplest machine learning algorithm that fits a straight line, a linear regression algorithm to make predictions. And with this, I would say that we've just completed what we intended to do last time, and that was to do linear regression given data. And when do we decide to use linear regression? It is when the data, our Y variable, is a continuous variable. With this, we have just completed a big chunk of what we decided to do last time. Now, without any waste of time, we're going to load our second data. So for my friend Adam that was asking about how we're going to use two data sets, if you wish, this is the chance to see how you can load two data sets. We're just going to continue with a second data set. Today, we're going to look at categorical data. And like I said, the categorical data, when your Y variable is categorical, then at that point in time, which machine learning algorithm should you use? You should use classification. And a basic machine learning algorithm that does classification, I said, is the logistic regression, which I showed on the slides before. And so we would just go and explore our data. I hope everyone has the data, the UCI card data set. So we're going to be using the UCI card data set. Let me just show us the UCI card data set. This is the UCI card data set, and we have so on the website of the UCI. Let me see if I can dig out the website for the UCI data set. Yeah, so the UCI car data set is accessible here. It is the data set has been existing for a while. If you go to this link, I can share this link with all of us after this. If you go to this link, there is much information about the data set, and the data set it contains information about cars, just as the name implies. The dependent variables, that is the variables, so there are some values about cars that are used to describe how accessible a car is. For instance, the price of the car. One of the variables is buying. That's how much is this price, that is the buying price for the car. Then the maintenance, price of the maintenance of that car. Then there are some other values that are used to describe a car still. Number of doors the car has, person capacity, the size of the luggage boot, and estimated safety of the car. So these are 6 variables that are used to describe a car. And based on these 6 variables, there's a value that decides that is used to say the attribute of the car. So based on these 6 variables, the data set says either the car is inaccessible, accessible, good, or very good. If you look at it critically, we could look at this problem as either the car is inaccessible, and we could just put all these 3 values into one as accessible. And before we start exploring the data set, still, I want to tell us what this how they describe these attributes. So when for buying, instead of putting the price, they just say the price is either very high, medium, or low. For maintenance, they say it is either very high to maintain, that's the price of maintenance. The cost of maintenance is either high, medium, or low. For those, they say it has 2, 3, 4, or 5 more. So 5 more maybe means more than 5, 5 or more. For persons, it says you can accommodate 2, 4, and this. So this is the information for the 6 variables. And before we load our data, I'll just show you the Excel sheet, the CSV file that we shared with you. This is the CSV file. So this first row just tells us what the variables are. So for buying, you can see in some columns it's very high, high, high. If you scroll down, you see some values are changing. And then we have maintenance, doors, and everything. So without waste of time, I'm sure it's not going to be hard enough for all of us to load this data. So let's just get back to our notebook and load the data. So can we all do this now? Data 2, you could call it data 2, equals to pd.read.csv, right? .read.csv, and then you just call the path. And what's the path? Don't forget, this is the path to our drive that we just mounted. Mount, drive, my drive, it goes all this way to data. Then you now call the CSV file. That is assuming you have the CSV file in your drive. Then we just call it car. This is the UCI underscore car dataset.csv. And just run that cell. Remember, you could run the cell by using the shortcut Shift Enter, or you could just click on the play button. So with this, I've just loaded the data 2. How will I know I've loaded? Remember what we did last month. You could say data2.info can give you some information about your data. See, it tells us these are the variables, buying, meant, this, and they are all 1,728. So the number of data in that file is 1,728. However, let's try something that we normally try. Let's try and say data2.describe. What is it going to give us? Not much information. Is it not surprising that it doesn't give us much information? Look at this one. When we describe, it tells us the mean, the standard deviation, the minimum data, 25%, and all this interesting information. But here, when we load this data, it doesn't give us that. What it tells us is it tells us the count, that's the total number of data. It says unique, and it just says top. It says frequency, that's it. It doesn't give us mean. It doesn't give us standard deviation. Can somebody guess why this is happening? It's easy to know that this is happening because the data that we are looking at today is categorical data. Sorry, so I'll close this one to avoid confusion. This data is categorical data. You cannot compute the statistics of high. What's high? You cannot compute the statistics of, even though here we have twos, but there are some values that are two more or something. So this is categorical data. Machine learning algorithms, and even us as human beings, we find it hard to say the statistics about categorical data. And this also applies to machine learning algorithms. So for all these algorithms that we're going to use, what you have to do first, which is very, very important. In fact, even if this is the only thing you take away today, is when you have categorical data, you have to convert it into continuous variables or to a numerical value. Because for instance, right now, for buying, the values that describe buying are very high, medium, and low. If you feed this into an algorithm, it's not going to work. It's just going to throw an error saying that it has a non-numeric data. So it expects you to give it a numeric data. And how do you convert this data to numeric then? For instance, for all of them here, none of them is numeric. So we have to find a way of converting them to numeric. There are several ways of doing this, and one of them is called the dummy coding. I'll tell you more about this dummy coding. So what dummy coding does is, look at this example I have for you here. For instance, if we had gender and age of people, look at this first table I'm showing here. Here, age is what? Is numeric. So this is not a problem. If you give this data to our algorithm, it's not going to complain about this. How about gender? The gender is not numeric, and so it's going to complain about this. To convert this gender to a numeric value, what we can do using the dummy coding is, we look at how many possible variables we have under gender there. It can either be male or female. So there are two instances for gender. Gender can either exist as male or female. So what we do is you call gender male and gender female underscore female. Wherever you have a male, you just ask yourself gender male. Is it a male? So if it is a male, then gender male is 1 for that value, and 0 meaning that gender female is 0 at this instance. And for this, the next one where we have female, it says gender male. The value is going to be 0 there because it's not male, and the value is going to be 1 here. So in a way, we'll just go through this process and encode this value. So if there are 2 instances in our data, it means you're going to have 2 new columns that will represent that data. Are we following? And so that means if you look at the UCI data set here, because buying has four variables that explain it, it means that for buying field, when we change it, it is going to give us 4 values. Wherever if it is very high, for instance, for the column that is very high, that place is going to be 1, 0, 0, 0. And that's what we're going to apply for all of them. So if you look at it, because all these data are categorical for these 6 values, we should expect 4 plus 4 plus 4 plus 3 plus 3 plus 3, about 20 something, maybe 21 variables if we use dummy coding. And how are we going to do this dummy coding? Are we going to do it by hand? No. In fact, Pandas has a way of doing this easily. All you have to do is just follow what I'm going to write today with just a single line. You see how to do it. So with a single line of code, this is what we have to do. So we could rename the data as data 3 or something just for us for convenience. If you like, you could overwrite what you have, your data 2. So what it says is we're taking this function get dummies. PD, which is pandas, we're calling pandas to do it. The function is from this library pandas. PD to get dummies, then pass in the data, that's the variable that contains the data, and list the column names that you want to convert. So here we're listing all of them, in fact, except the value, because there's a value field. Don't forget there's a value field in our data. This value field is the y-axis, is the dependent variable. So we are going to treat this one in a different manner. Why are we going to treat it in a different manner? The reason is because it has 4 values, and for today, it has 4 values: unaccessible, accessible, good, and very good. But what I want us to do is just to use it as unaccessible, and we're going to classify everything here as accessible. So we'll get back to our notebook and just run that line of code. After running this line of code, try and write data.describe now and see what happens. Sorry, data2.describe. See? So that means now it knows. And you can see the column names have changed. Buying high, buying underscore low, buying underscore medium, buying underscore very high. And that's how it continues. So now we have 21 variables. There's one variable that is extra. Let's see. How will we know? Let's just write data2.info. Run this. You see, we have value. Value is the only one we haven't touched. But this, you can see that our other variables have been converted into dummy coding, and it is telling us the data type is unsigned int 8. Well, if you looked up here, it says what the data type, it just says object. So that's why if you feed this in, it doesn't make sense to the algorithm. But now if we had to feed this in, it will make sense for the algorithm. But wait, we are not yet there. Value, if you print what's in our value, data2 dot value, which is, it just shows accessible, inaccessible, very good, and all this. So these are still not numeric. So we have to change these values into numeric. And in fact, like I said we want to group them into unaccessible and anything that is either good, a card that is good or very good or accessible. We're just going to call it accessible. Why are we trying to do this? Because the classification algorithm we hope to look at today is logistic regression. And logistic regression, which is used, it is mainly used for classifying things into 2 classes. But here we have 4 classes: unaccessible, accessible, very good, and good. Well, there is a general form of logistic regression, but this one advanced course. But for what we are looking at today, we're only going to consider a 2-class classification problem. So what we're going to do here now is I'll do a little bit of I'll write a small program that will do something. If it is confusing, don't be put off. Don't feel intimidated. Copy it, go along, and when you study this after today, I'm sure it will begin to make sense. And there are many online resources that will explain this. So what we're going to do is I'll write a function that just takes whatever we have here in this column, and it will apply it to the data and convert it into either unaccessible. We'll write whenever data is unaccessible, we'll change it to a value of 0. While anything either accessible, very good, or good, we'll write it as 1. And what I'll do is I'll write a function. Just follow along. Don't feel intimidated. We'll call a function value to numeric. So I'll just create a function like this, and I'll say if the value is unaccessible, you should just convert it to 0. Yeah. And if the value is, if it is any other thing, if it's accessible, very good, or good, we return what? We return 1. So with this, I'll just run this function. I haven't applied this function to my data yet. The next thing is I'm going to apply that to my data. And in fact, I want to apply it to a specific field. So what I'll do is I'll create another field, which is called in my data2, and I'm now adding an extra field called value numeric. I'll call data2 value. That is, you could either put dot or you could put this square bracket. It all works. You can see here I just use dot. So even here, if I wrote dot here, it will work. So I'm going to take that field, that column that has all these values, and I'll apply. So pandas uses this function called apply, and we'll just apply that directly into, we'll apply it using this function. So what it means is we're passing the data to that function one at a time, and you just do it in one shot. And if I did this, now we have an extra field. Let's just write data2.info, and you see what I mean. So I hope we're following. All right, fine. So if we are following, okay, let me go back to my notebook, because I was showing you the full screen. I was just thinking that maybe there will be questions. Okay, so let's get back to our data. And so here you look at, after writing data2.info, you see that we have the field called value, which we had before, and then we have a new field now called value numeric. If you check this value numeric now, you see that it has converted all the data into numeric values, and that would be really cool for our machine learning algorithm. So you see, whenever it is unaccessible, it is 0, 0, 0. If it is accessible, it's 1, 1, 1. Unaccessible, 0. That's excellent. So that means now we have a value here, a column in our data, which is value that is of no use for us, because it is not a numeric data. So we can just remove this. And an easy way of doing this is we'll just use our our friend pandas has another function called drop. So if you say data2, we're going to overwrite it, because the data2 dot drop. And what we're going to do here is we'll just call the name of the field that we want to drop. And don't forget, there's an axis parameter for the mean time just right axis equals to 1. And when we do this, it means that it has removed that field. And if we were to write data2.info, what will happen now is you see that the value field is no longer there. Yes, so it just starts from buying. So now we have just 21 values, 22 color fields, which makes it very suitable for our work. So if you are to write .describe, you see that our describe has buying, it all goes all the way to our value numeric. You can see value numeric is the last column here, the last field there. So what we have here is the value numeric is going to be our dependent variable. And all the other values, the other 21 values are the what? Independent variables. So we're going to feed this into X, and we're going to feed that into Y, and we're going to try and do classification. As easy as that. So I'm sure you'll be thinking, so what's next? You remember what we did here. We'll split the data. So we can just split the data we have. So what we have is X, we can say it, that X is equals to data2, the whole of data2 is going to be X, except what? One column, which is value numeric. So we could just say data2 dot, we use the function we just learned now, drop. So we'll just say data2 dot drop value numeric. So if you remove value numeric from data2, it is going to be X as our X data, because everything is X. That's X. And then our Y is going to be just data2 dot value numeric. So that's our data2. Let's see the shape. Let's see the data we have. So if we were to say X dot shape, you see we have 178 rows and we have 21 columns, which are these are dummy variables. You remember how we created them, the 21. Then we have Y dot shape. It should be just a single column, and that's it. So now we have our data. So we have our X data and we have our Y data. You shouldn't worry, even if the speed we're going at today is quite fast. I feel that with the resources you have and with the fact that we're going to share this notebook with you, you should be able to go over this and you will even understand what we're doing even further. So after getting this data, the next thing is we're not yet ready for our classification problem. But the next thing we'll do is, you remember what we did? We have to split our data. You remember in machine learning, whenever we have our data, the first thing is we have to get a big chunk of the data which we're going to use for training. Because it is a supervised machine learning algorithm, it needs to see the X and the Y. And we'll do the same thing that we did for our linear regression. So here we'll just say X train, and to avoid conflict, we'll say X train 2, X test 2, Y train 2, Y test 2, so that our data that we use for linear regression above doesn't get touched. We'll now use the function called train test split. Remember, it requires you to give it X and Y, and it requires you to tell it the test size. We'll also stick to 0.2% for test size, meaning that 80% of the data will be used to teach the algorithm, and the remaining 20% we'll use it to evaluate to see how good are we performing. And then don't forget you should write random state, because it does this shuffling randomly. So if you use a random state, if you want to replicate this or your friend wants to copy this from you, if you use the same random state, the data splits will be the same just like yours. So now let's run this, and let's just look at the shape of our X train, just to be sure of what we're doing. X train 2, the shape, you see that it should have 21 columns, 13282, which is 80% of 1728. And if you look at our X test 2, the shape, you see that it's just 20% of the data. We're almost there. We're almost there. So with this, we have our data, X training data and X test data, and we're almost ready to do our training. But wait, there's a problem here. Our data is not balanced. There's something called an imbalanced data set. So what it means is sometimes the data you're using might be unbalanced. What it means is the data describing one class of your dependent variable might be the size of one particular type of data might be higher than the other one. So for example, in what we are talking about today now is for the unaccessible class, if I showed you, you see that unaccessible cars are far more than the accessible cars. And if you train your algorithm that way, because the data is imbalanced, it is going to affect the accuracy of our algorithm. So what we're going to do is, first, we have to replicate our data. That is, the smaller, you look at the smaller data, replicate it, make it as much as your huge data, then you have a balanced data set. Then that is when you'll be able to train. We might go a little above 1 hour, but if you'll be happy to hang on, we should be able to get there. So the first thing we're going to do is, and we don't care about our testing data. We don't care about the testing data. It is the training data that has to be balanced, because that is what we're going to use to create the machine learning model. And if it is not as intelligent enough, then there's going to be a problem. So now, before we do that, I'm going to do something that is counterintuitive. Our X trend and Y trend, I'm going to put them together so that whatever I'm going to do with the shuffling and everything, I'll be shuffling, instead of just shuffling the X data and shuffling the Y data separately, I'll put them together so that I'll shuffle them together. So what I'm going to do is just follow along. The first thing is I'll combine them. I'll combine the data and maybe call them trend data. And don't forget, we've learned how to combine data. We know with pandas gives us that function called concat. So I can just call X trend 2 and Y trend 2. So I'll just call these values, and don't forget to say the axis. That is the axis on which we are combining. So now we've combined our data into this single variable. And then I'll go and look at how many accessible data we have and how many unaccessible. You remember our Y variable is what gives us the accessible, how many accessible data we have and how many unaccessible. So the accessible data, you see that they are the values that we set are 1, right? And unaccessible are the values that are at 0. So we'll just use 2 lines of code to check this. I hope you're following along. So I can just call these 2 lines. Trend data, unaccessible data is our trend data, where our trend data dot value numeric is equal to what? 0. And accessible data is our trend data when the value numeric is 1. If you run this, and let's try and print the shape of the 2. Print the shape of unaccessible data dot shape and accessible data, that is accessible, the data that represents accessible cars, and unaccessible means unaccessible cars, right? So forget the slip of the tongue. I've been saying accessible data. So let's see. You can see we have 950 unaccessible cars and we have 432 accessible cars, meaning that the data is not balanced. So if we train our algorithm this way, the accuracy isn't going to be affected. And so what we have to do now is we have to replicate this data, resample it, we have to pad it up. So that's for the accessible data, which is smaller. The smaller data has to be padded up to meet the size of the huge data. And how do we do this? I've already imported a library at the top. If you come here, and this is why Python is so sweet and so easy, because most of these things you don't have to do it you don't have to write a code. You just need some few lines and it does it for you. So sklearn, this library, that the machine learning library, already has a sample in this class utils. So what we do is we'll just go here and you see what we do. It's just a single line. It might be daunting to you, but I'm sure after this, if you go over all we've done, you see that it's just one thing. You will see that it is not much we're doing. It's just a line of code that will do this for us. So this single line of code, resample is the name of the function. We pass the data that we want to resample, that's the accessible data, that's data that is small. We'll pass it and we'll say replace with true, and then if time permits, I'll explain all this. Then we'll say it should sample the number of samples, because the function expects you to tell it how much do you want me to pad it. So what it means is you're going to get your 432 rows and you're going to replicate them just to pad it up. To what size? Here I'm saying the length of 950. So if I wanted here, I could just say to 950 and no harm done. So if you like, you could write 950, or you could just say the length of the unaccessible data, because we want the accessible data to be resampled to be of the same size. So if you run this, and if you are to write accessible data of sample dot shape, what's the size? 950. So it's now the same size as this. We've just taken our data and replicated them. So now we have two data samples. This is for our accessible data, and this is the unaccessible data. We've made their size to be the same. I hope you're following, and I hope you're not getting tired. We'll almost hit our 1 hour mark. And like I said, just to round up this thing, we might just go over the 1 hour time by maybe a few minutes. Now, having done this, we have balanced our data set. We have a balanced data set. Now, it is time for us to combine these two rows or these two values that we have. Combine them, split our X and Y, and then go ahead with the training. So this is what we have to do now. So to combine, you remember pd.concat that we're just going to use. So all we're going to do is we're just going to say combined, or whatever, if you like, you could call it upsampled data equals to, we'll call pandas.concat, we'll combine the two data sets. So unaccessible data and the upsampled accessible data upsampled. So if you run this, you see that I didn't call the axis. By default, if you don't call the axis, it says axis 0. So it will stack them one on top of the other, and that's what we want. And now, if you were to check the shape of that upsampled data, you see that our upsampled data should be of about 1,800 or 1,900. Yeah, 1,900. So you can see that data now is far more than what we had for the training. And don't forget, all this we've been doing is for our training data. We haven't touched our test data. The test data, we don't care, because we are not using the test data for training the model. We just want to train the model, because this was what we had before, 1,382 lines. If we train the algorithm with unbalanced data, it will be an issue. Now we balance our data. Then next, we have to get the X out and the Y out. You remember we had to combine the X and Y so that we do all this together. So what we can do now is we just say X train. So now you could just say X train 2. We're going to replace our former X train 2 is going to be upsampled data dot drop. The same thing we did before. Value numeric, because value numeric is what is our y data. And don't forget, here you must say the axis. That's to say the axis is along the vertical axis. And then y train 2 equals to upsample data dot, and now we're going to just call the value numeric. We've split the data. And yes, so finally, I hope you are following. Finally, it is almost 1 hour now, and finally we just split our data. So what have we done so far? Besides what we did in our last to round up what we started, where we stopped last time, which was the linear regression we finished. But so far what we've done is we've taken a data set, which is a CSV file, which contains categorical information, and the data is not numeric, it's just text information and some numbers that are combined with text that are in the data. And so the first thing we did was we converted the data, which is text information, into numeric values. And that was where I taught us how to use dummy coding. So we've converted everything into numeric data, which machine learning algorithms are expecting. And then next, we looked at our Y variable. Our Y variable has 4 classes. It has unaccessible, accessible, very good, and good. And we said for today, we just want 2 classes. So we combined accessible, very good, and good classes into one, and we gave them a value of 1. While unaccessible data, we gave them a value of 0. Then the next thing we did was we looked at the data. We wanted to start training. After splitting our training data and our test data, we wanted to train a logistic regression algorithm. But we now said, let's look at the data. Is it balanced? We looked at, we saw that the data is not balanced. Unaccessible data has a huge number, and the accessible data has very small. So we made sure that accessible data is as much as the unaccessible. And what did we do? We just took the unaccessible data and we just replicated it. We just repeated them and filled up the size. So if there were 432, we just repeated them to just reach the number we wanted. And now we have the data, we've split it, and we're just about to do logistic regression. It's not going to take us more than 10 minutes to round up this. So to do logistic regression, it's just a single line as well. We have our X trend, we have our Y trend, and for the logistic regression, the good news is I've already imported a library that does it here, sklearn. You can see from sklearn linear model, we imported linear regression. That was what we use for linear regression. For For logistic regression, is just the slide. And the metric that we use for logistic regression for classification algorithms is accuracy score. Don't forget, for regression algorithms, we use mean absolute error. And please, just to call our attention, the name logistic regression should not be confusing. Logistic regression has regression in the name, but it is a classification algorithm. Linear regression is a regression algorithm, and it also has a regression in its name. So please don't be confused. Logistic regression, this I know confuses people. Sometimes it is called logit. So logistic regression, remember the logistic, it is a classification algorithm. Yeah, so let's go and finish up with this. And so because we already have sklearn, we have already imported the function, all we have to do is we just create a model similar to what we did in linear regression. What we do is slightly the same. So here is we can call it model 2 dot model 2 equals to logistic regression, and logistic regression model is just like the linear regression. If you did this and run it, it's just the same as what we did for linear. You first define an instance of the algorithm. But logistic regression expects one variable called the solver. For the meantime, you don't have to disturb yourself about this, but for advanced machine learning courses, we can explain this. But for the meantime, just stick to linear and it will work. Even if you didn't define this, it will work. It is just that it will throw an arrow, a warning. It will just give you a warning. Let me try and run it without that so that you see what I mean. So if you did this, sklearn will run. Oh, it did not even complain. So that means my Google Colab doesn't complain. So since it doesn't complain, it uses the default. It uses the default solver. So let's just go ahead with it for simplicity's sake. Then after defining a model, remember what we did last time. Then we call the fit. The fit is what does the training. So just a model 2.fit, and then we pass xtrain 2 and ytrain 2, and this is just what does the training. Now it is training. It has finished training so fast. So train a logistic regression model. What's the next thing? We should try and make our prediction. And whenever I want to do prediction, I said we predict on the data that the algorithm has not seen. So we now take our what? X test. You remember X test 2? That's what we use for prediction. So ypred2 is equals to model 2.predict. Predict. As easy as that. And you just pass the data X test 2. We finish our prediction. So now we have our prediction in ypred2, and we remember the real values for X test 2 are in what? Y test 2. So how are we going to know how good we're doing? There's a function that I've imported, which is the accuracy score. And with the accuracy score, all you have to do is to pass the two values, just like we did for mean absolute error. So we can say prediction accuracy. So prediction accuracy is equals to accuracy score. So it is accuracy underscore score, and then you pass the two values, the y test 2 and ypred 2. With this, if you run this, and now let's print the value of our accuracy, prediction accuracy, just for us to see what is the prediction accuracy. Okay, I had a typo in my typing. .79%. That's our accuracy. So we predicted with 94.79. In fact, if you are to round this, we could round the value and multiply by 100 just to make it look good. So we could just say the prediction accuracy. There is a round function in Python. If you write round and then on comma, let's say to 2 decimal places and multiply by 100. 95% accuracy. So our logistic regression model that was just trained on this data, it predicted our test data. It has not seen this test data before. 346 values were sent to it, and it predicted the Y value. That is, it predicted them to be either accessible or inaccessible with 95% accuracy. So that's it. We've gone through two basic machine learning algorithms. We looked at linear regression, and we use linear regression for continuous variables. When you have your dependent variable, that's your y variable, if it's continuous, what is continuous? In the layman term, if it has points in your data, that is 1 point this, 2 point this, the data is not discrete, then you are supposed to use regression. And we use linear regression, and you've seen that was just part of the completion of what we did in our former course. For this one today, which was categorical information, we've classified cars, given their buying price, their maintenance price, and how many doors they have, what was their boot capacity, how safe are they. With all this information, we took some of the data, 80% of the data, and we trained a logistic regression algorithm, which is a classification algorithm, and we now gave it the data that it has never seen. That's 20% of the data that we held back. So X test was the data that we held back. We took that data and we asked it to predict for us, and it predicted with 95% accuracy. This is the end of this course, and thank you for being with me. Thank you for joining us. I will accommodate a few questions if there are, and if there are no questions, we are going to call it a day. We're going to upload this video to YouTube, and we're going to upload the resources as well. The notebook that I used, for instance, for people that are not typing that fast. And please don't feel intimidated. These things, I'm sure they look new to you, some of the functions that we're calling, but just keep on at it. Get some data that is specific to your own problem. Go to your department, go to your, maybe you have some real life applications, some projects that you have in mind, form some categorical data, or get some continuous data, or wherever. Try and experiment with this. The best way to get this, to learn these things, is by practicing. It's not by just reading. That's the slightly different approach. Whenever you see things like this, try and code them, do them more and more and more, and before you know it, you see that you are not a professional. Some of the things I wrote there that are not quite clear to you, copy them, stick them into Google. You find some very nice tutorials that will tell you the basics. I decided to make this a little bit different. And so, okay, so during the reward, if you want to communicate to us, you can we'll drop an email. So maybe we'll stick an email underneath to us. If you go to Science Communication Hub Nigeria, there should be a contact us. But I think I will communicate with Dr. Mahmoud on how to, what's the best way to approach this. Okay, so what we can do is we'll get an email underneath to just for you to be able to communicate with us. There'll be an email under this, and you can even stick your questions under the comment section on the YouTube channel. We should be able to answer you. Is there any other question? Okay, so the question is, can you explain what you mean by inaccessible? All right. So this is a good question. What I meant is, Muhammad Tukur, what I meant was the data that we're given. So let me just show us. The data that we worked with today is this data set, and this is it. So, and the data, like I said, can be accessed here. If you come to this, we'll post this link, or just check car evaluation data set. It is here at this link. It is the UCI car data set. The UCI car data set is, let me see if it opens. Let me just quickly check it on Google. So if you went to Google and write the UCI car data set, this is a well-known data set that has been used in machine learning. So here is information about the data that we use today. So the car accessible and inaccessible are just attributes. What this data set does, what this data set entails is you have the 1,728 information about cars. Whether the car has 4 doors, whether the car has 2 doors, whether the car can take 2 people, 4 people, and what's the price value of the car? Is the car very expensive? Is it very high? How is the maintenance of the car? Is the maintenance of the car very high? So there are information about cars that they gathered. And then they now label the cars. So they gave values to the car. So the car value was, this car is unaccessible, meaning that maybe this car should be written off. This car is too expensive, it's too hard to maintain. It is better you don't, it is better you don't go for this car. And then there's another category of information they gave about the cars where they said they are accessible. And then there were some that they even said the cars are very good and some cars are not too good. And so we just took that information. And of course, this information is about either the car is accessible, inaccessible, very good, or good. These are what? Dependent variables. They depend on what? Those 6 values, it's just 6 attributes that define the car. And so we decided to use this as a machine learning problem to solve. So this is not something that I defined, it's just part of the data set that we looked at. I hope that explains that, Mohammed Tukur. So with that, we'll say thank you very much, and feel free to access this. And now my last advice is get your hands dirty. Get data, get your own specific data. Try what we've done today. The notebook is going to be given to you. We will share our notebook. Feel free to drop comments on the YouTube channel. Thank you very, very much.